Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, hope you all are fine. I am Aleena Kausar from Peshawar Model Degree College, Haripur campus. Today I am going to discuss the very important topic from chapter number 2 of first year chemistry, that is quantum number. Our today's lecture consists of the background of quantum number definitions, and the set of four quantum numbers, that is the principal quantum number, azimuthal quantum number, magnetic quantum number, spin quantum number, and the tables that summarizes all the four quantum numbers, and the last part is assignment. So first we are going to discuss the background of quantum numbers. Bohr's atomic model gives the concept of orbit. Objections were being made on Bohr's atomic model about the movement of electron in 3D space and the spectra of polyelectronic atoms. Bohr's atomic model failed to justify these objections. In 1926, Erwin Schrödinger developed an equation called Schrödinger wave equation, in which electrons are treated as moving with wave-like motion in 3D space around the nucleus. The solution of Schrödinger equation gave a set of numerical values that are actually the quantum numbers. And now we are going to discuss the definitions of quantum numbers. So the first definition is the quantum numbers are the certain numbers that give complete description, that is the energy and the shape of orbitals of an electron in an atom. Or we can say that the set of four numbers which completely describe the location of electron in an atom. The four quantum number, which tells us the complete electron's address, or the principal quantum number represented by the symbol n, azimuthal quantum number represented by the symbol L, magnetic quantum number represented by the symbol M, and the last one is the spin quantum number represented by the symbol S. The first quantum number is the principal quantum number, which gives the complete information about shell or orbit in which electron is present. It is represented by the symbol n. Its values start from 1, 2, 3 up to so on. The principal quantum numbers tells us about the size of atom and the energy of electron. Greater the value of n, greater will be the size of atom, and lower the value of n, lower will be the energy of electron. To find the total number of electrons in an orbit, the formula is 2n square. When the value of n equals to 1, the name of the shell is K and the number of electrons is 2. When the value of n is 2, the name of the shell is L and the total number of electrons present in L shell is 8. The total number of electrons present in M shell is 18 and the total number of electrons present in N shell are 32. The next quantum number is the azimuthal quantum number. It represents the subshell present in main energy level. It is represented by the symbol L. Its values start from 0 up to n minus 1. L defines the shape of subshell. When the value of L is 0, the subshell is S and its shape is spherical. When the value of L equals to 1, the subshell is P and its shape is dumbbell shape. When the value of L is 2, the subshell is D and its shape is double dumbbell. And when the value of L is 3, the subshell is F and its shape is complicated. When the orbit is K, the value of N is 1, the value of L is 0, the subshell is 1s and the number of subshell is 1 and the number of electrons present in subshell is 2. To find the number of electrons in each subshell, the formula is 2 into 2L plus 1. When the orbit is L, the value of N is 2. The value of L is 0, 1. The subshell is 2s, 2p. The number of subshell is 2 and the number of electron is 6. Shape of s orbital. The shape of s orbital is spherical. The shape of p orbital. The shape of the p orbital is dumbbell. The two lobes are present along x-axis in 2px orbital. The two lobes are along y-axis in 2py orbital. The two lobes are along z-axis in 2pz orbital. The shape of the d orbital is double dumbbell, which are given. The third quantum number is the magnetic quantum number. It explains the effect of an orbital in magnetic field, that is the orientation of an orbital. It explains the magnetic properties of electrons. Orbitals split up into degenerate orbitals. Degenerate orbitals are those having same energy and shape. When the orbitals split up into degenerate orbitals in a magnetic field, so that each degenerate orbital can hold up to 2 electrons. The magnetic quantum number is represented by the symbol m, and its values start from 0 up to +1 and -1. When the subshell is S, the value of L is 0, then M is 0. So the degenerate orbital is 1 and the number of electrons is 2. When the subshell is P, the value of L is 1, the value of M is 0, +1, -1, and the number of degenerate orbital is 3, and the number of electrons is 6, as 2 electrons are present in each orbital. The last quantum number is the spin quantum number. It describes the direction of spin of an electron. Electrons which rotate around the nucleus also rotates around its own axis. This is called self-rotation. It is represented by the symbol S. Electron can spin clockwise or anti-clockwise. There are two possible values of S that are equal and opposite. When S equals to -1/2, it is clockwise spin, and when S equals to +1/2, it is anti-clockwise. Here is the diagram which shows the spin of electron associated with magnetic field. Here is the table that summarizes all the 4 quantum numbers. At the top of the table there are quantum numbers like principal quantum number, azimuthal quantum number, magnetic quantum number, and the spin quantum number. When the value of n equals to 1, the value of L is 0 and the value of M is 0. So there are two possible spin, +1/2 and -1/2. When the value of n equals to 2, then the value of L is 0 and 1. So the value of M is 0 and 0 +1 -1, and the spin is given. This table also summarizes the 4 quantum number. In this table, the name, the symbol, and the values and the importance of all the 4 quantum numbers are given. And at the end, there is the assignment for my dear student. Write down the answers to the following conceptual questions. Thank you very much, my dear student.